Hey everyone! Now, have you ever wondered why you feel that nice cool chill after you sweat? Or why a pot of water for Eba bubbles like crazy, but a puddle outside just disappeared slowly in the sun? Well, those are the exact kinds of questions your examiners are going to ask, and today we are going to master the answers. Welcome to our deep dive into evaporation and boiling. Trust me, this topic is a guaranteed high score in your WAEC, JAMB, and NECO exams. By the end of this, you're going to feel so confident you'll be able to tackle any question they throw at you. Let's jump right in. Alright, so what's our game plan for today? It's simple. First, we'll look at why examiners are obsessed with this topic. Then, we are going to break down evaporation. And after that, we'll tackle boiling, making sure everything is crystal clear. And the best part, we are going to solve real past questions together, so you see exactly how to apply what you've learned to get maximum marks. Then we'll wrap it all up with a quick summary and some killer exam tips to help you lock in that A1. So why are we focusing so much on this topic? Think of it like a secret key. Examiners love it because it unlocks your understanding of a massive concept in physics, the kinetic theory of matter. If you can explain evaporation and boiling using this theory, you're basically telling them, hey, I have a rock-solid foundation in physics. Trust me on this one. The marks you can grab from mastering this topic are huge, and it's one of the most reliable ways to give your overall score a nice boost. Now, don't worry. We are not going outside of what you need to know. Everything you see right here on the screen, it's taken directly from your official WAEC, NECO, and JAMB syllabus. We are going to cover every single point you see here so you can walk into that exam hall with full confidence, knowing you are perfectly prepared. Alright, let's get into our first big idea, evaporation. You see this every single day. When your wet school uniform dries on the line, or when you feel that cooling feeling as your sweat just vanishes from your skin. So what's actually going on? It's like a great escape of water molecules, breaking free from the surface of the liquid and just heading out into the air. To really truly understand evaporation, we first have to master the kinetic theory of matter. This is the bedrock, okay? It basically says that everything, solids, liquids, gases, is made of tiny particles that are never ever still. They are always moving, vibrating, bumping into each other. And here's the golden rule you must never forget. Temperature is just a measure of the average kinetic energy of these particles. Say it with me. More heat, more speed. A higher temperature means a higher average kinetic energy. This link is the foundation for everything that comes next. Okay, let's get the official definition that the examiners are looking for. Evaporation is the slow escape of molecules from the surface of a liquid, and it can happen at any temperature as long as it's below the boiling point. The words you need to remember, the key words that get you the marks, are slow, surface, and any temperature below the boiling point. It's a quiet process happening all around us all the time. This is a classic WAEC question. You are feeling hot, you start to sweat, a little breeze blows, and all of a sudden you feel cool. Why? Just take a moment and think about that kinetic theory we just covered. What is really happening on your skin? It's not magic, it's pure physics. It's the exact same reason why dabbing methylated spirit on your skin feels so cold. Let's break it down. So, here's the secret. Inside that liquid on your skin, the molecules are not all moving at the same speed. It's like a big crowd of people. Some are walking slowly, some are jogging, and a few are just sprinting. The ones that escape, the ones that evaporate, are the sprinters, the Usain Bolts of the molecular world. They have the most kinetic energy. So, when these super fast high energy molecules escape, who is left behind? The slower ones. This brings down the average kinetic energy of the whole group. And what did we say temperature measures? Average kinetic energy. So, if the average KE drops, the temperature of the liquid left on your skin drops, and you feel that nice cooling sensation. See, it's a perfect direct application of the kinetic theory. Okay, so what things can speed up or slow down this great escape? Examiners love to ask about these 4 factors. First, temperature. Obviously, on a hot sunny day, your clothes dry in no time. Why? More heat means more molecules have that high energy they need to escape. Simple. Second, surface area. This is just common sense, right? If you spread your shirt wide, it dries faster than if it's all crumpled up in a ball. More surface area means more escape routes. Next is wind. A good breeze is like a taxi service for the escaped water molecules. It carries them away, making space for more molecules to leave the cloth. And finally, humidity. On a really humid day like in Lagos during the rainy season, the air is already full of water. It's like trying to get on a packed bus. There's just no room. So it slows right down because the air can't take in any more water molecules. Alright, let's switch gears and move to the second process, boiling. You see, while evaporation is a quiet, surface level kind of thing, boiling is way more dramatic and energetic. Just think about the difference between a puddle drying quietly in the sun and a pot of water bubbling violently on the stove to make eba. They are both liquid turning to gas, yes, but they are fundamentally different. And here's the official definition for boiling. It's the rapid vaporization of a liquid. Now, the 2 keywords to contrast with evaporation are rapid and throughout. It happens everywhere inside the liquid, not just on top. That's why you see bubbles forming at the bottom of the pot and rising up. And this is crucial. It happens only at one specific temperature. We call that the boiling point. For pure water at sea level, that's exactly 100 degrees C. No more, no less. So what actually triggers boiling? Well, it's a battle of pressures. Imagine the air all around us is like a heavy blanket pushing down on the surface of the water in your pot. That's the atmospheric pressure. At the same time, as you heat the water molecules are pushing upwards, creating their own pressure from the inside. We call this the saturated vapor pressure. Boiling begins at the exact moment that the upward push from the water becomes strong enough to equal the downward push of the air. When they are equal, the water wins the fight and bubbles can finally escape. This is exactly why food cooks faster in a pressure cooker. The extra pressure inside raises the boiling point of water way above 100 degrees C. Have you ever noticed that once water starts boiling, its temperature gets stuck at 100 degrees C? You can turn the gas up as high as you want, but it stays at 100 degrees C. This is a massive concept. The reason is something called latent heat, which really just means hidden heat. Think of it this way. The heat energy you're adding has 2 jobs it can do. Job number 1 is to make the molecules move faster, which increases the temperature. Job number 2 is to break the bonds that hold the molecules together as a liquid. At 100 degrees C, all the heat energy stops doing job 1 and focuses completely on job 2. It's using all its power to break those bonds and turn the liquid water into gas or steam. Since it's not making the molecules move any faster, their average kinetic energy and therefore the temperature stays locked at 100 degrees C until all the water has become steam. Okay, screenshot this slide, write it down, do whatever you need to do because a distinguished question is almost guaranteed in your exam. Let's walk through the key differences so you never ever mix them up. First, location. Evaporation is a quiet, surface-only thing, like a puddle drying. Boiling is a party happening throughout the entire pot. Then, temperature. Evaporation happens right now on any water surface at any temperature. Boiling is very picky. It only happens at that specific boiling point. Think about the bubbles. You never see bubbles in a drying puddle, but they are the signature sign of boiling. And finally, the heat source. Evaporation just takes its energy from the surroundings, but for boiling, you have to supply a constant external source of heat, like a stove. Remember these points and you'll be set for that question.
Alright, now for the part you've been waiting for. We've gone through the theory, we've broken down all the concepts. Now let's put it all into practice and see exactly how you can secure those full marks in your exams. We are going to solve real past questions from WAEC, from JAMB, and from NECO. You are so ready for this. Let's go. Let's start with a classic from WAEC. This is a two-part theory question, and it's a real test of your understanding. Now look very closely at the instruction. Using the kinetic theory of matter. That's a direct command from the examiner. If your answer doesn't mention molecules, kinetic energy, and intermolecular forces, you just won't get the marks, even if you kind of know the answer. So let's break down how to craft that perfect response. So for part I, about cooling, the key is to state that molecules in the liquid have a range of different kinetic energies. The fastest, most energetic ones at the surface are the ones that escape. This action lowers the average kinetic energy of the molecules left behind. And critically, since temperature is a measure of average kinetic energy, the temperature of the liquid drops. Simple. For part II, about boiling, the examiner is looking for that magic phrase, latent heat of vaporization. You must explain that the heat being supplied is used to do work, the work of breaking the intermolecular bonds to change the state from liquid to steam. It is not being used to increase the kinetic energy of the molecules. Therefore, the temperature stays constant during this phase change. That right there is a full marks answer. Next up, a typical JAMB question. Now, multiple choice isn't about guessing. It tests how precise your understanding of the definitions is. Let's read it carefully. The process whereby a liquid turns spontaneously into vapor is called. What is the one keyword here that unlocks the whole question? The correct answer is, of course, B, evaporation. And the keyword that just gives it away is spontaneously. Spontaneous means it happens on its own, naturally, without being forced to a specific temperature. That is the very definition of evaporation. It happens at any temperature on any liquid surface. Boiling is not spontaneous at all. It's a forced process that requires you to supply heat until you hit a specific boiling point. Do not fall into that trap. And finally, a very common question from NECO. It's a direct, straightforward instruction. Distinguish between evaporation and boiling. When you see this, you should be happy, because this is an opportunity to score some really easy marks if you are well prepared. This is where that comparison table we talked about becomes your absolute best friend. Look, to get full marks on a distinguish or differentiate question, the best cleaner's approach is always to use the table. It's clear, it's neat, and it shows the examiner you know exactly what you are talking about, point for point. You list the features like location, temperature, and process down the side, and then you just state the clear differences for both evaporation and boiling side by side. This format stops you from forgetting points, and it makes sure you get every single mark available. This is the A1 strategy. Whew, we have covered a lot of ground today. Fantastic work sticking with me. You've learned the theory, and you've seen exactly how to apply it in exams. Now, let's just wrap it all up with a quick summary and some final tips that will make all the difference when you are revising and on exam day itself. Let's lock in these key formulas and relationships. First, the heart of kinetic theory. Average kinetic energy is directly proportional to temperature. More heat, more speed. Second, latent heat. That hidden energy needed for a state change is calculated as Q equals mLV. And third, the trigger for boiling. The internal vapor pressure must be equal to the external atmospheric pressure. Keep this slide handy for your final revision. And here are my top tips for this topic. 1. Use the keywords we've been talking about. Examiners are specifically looking for them. Words like surface, throughout, average kinetic energy, and latent heat are your keys to full marks. 2. In a theory question, a simple, well-labeled diagram showing molecules escaping a surface can earn you an extra mark. 3. I can't say it enough. For distinguish, differentiate questions, please use a table. And 4, my personal favorite, try to explain these concepts to a friend or your brother or your sister. The best way to know if you've truly understood something is to try and teach it to someone else.
And that is a wrap on evaporation and boiling. Listen, I want you to know that you are more than capable of mastering this topic and smashing your physics exam. You've put in the work today, you've seen the concepts, and you know how the questions are asked. You have everything it takes. You can do this. If you found this lesson helpful, please do me a quick favor. Like this video, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB, and subscribe to our channel right now so you don't miss the next topic. Also, make sure you visit www.examkp.com for thousands of free practice questions and answers. Let's smash these exams together.